When we're talking about relations or graphs of data, we often use the word domain and range to talk about the x and describe the x and the y values of our relation. So the domain, we can talk about the domain being all of the possible x values, that's the independent variable, of a relation. So the domain are all the possible x values, and the range is all of the possible y values. The y values, of course, being the dependent variable of a relation. And we know that there's different ways that we can describe the relation. So one way is a set of ordered pairs. So if I make some points up here, say 3, 7, 2, 1, 7, 5, and 3 minus 2, then the domain would be the first coordinates in the set of ordered pairs. So these are all the x values. So the domain of this function would be 3, 2, 7, and then we've got 3 again, so we don't need to mention that twice. So the domain would be 3, 2, and 7. Those are all the possible x values. And the range of this function is the second coordinate. Obviously, that's our y value. So the range would be 7, 1, 5, and negative 2. That would be the range of that particular relation. The other way we could do this is we could put these, of course, in a table of values. So if I put these same points in here, 3, 7, 2, 1, 7, 5, 3 minus 2, then the domain would be expressed by the possible values in the first column. Those are our x values. So the possible x values are, again, 3, 2, and 7. And the range, the y values, that's the possible values in the second column, would be 7, 1, 5, and minus 2. Another way we can describe the domain and the range is we could draw ourselves a graph. There we go. Let's put a little graph on here. Come on, pen, please. So if I start my graph here, and end my graph here, and let's put some points on here, or coordinates rather. Then on this one, so I've used some different points here than the first two examples. The domain would be the possible values on the horizontal axis of the graph. So this is my horizontal axis, and it looks like my x values start at negative 4. Remember, this is your x-axis, this is your y-axis. So the possible values in the horizontal axis is basically saying how far left and right does this graph go? Well, it goes from minus 4 all the way to 3. So the possible values in the horizontal axis are all x values from minus 4 to 3. And we'll talk about this in a little more detail a little later on in this video about how we could write the domain and the range. But you should be able to see here that the possible values in the horizontal axis are from minus 4 all the way to 3. And then the possible values on the vertical axis, so how far up and down does this graph go? Well, it starts at minus 2 and it goes all the way up to positive 3. So we could say the range would be all of the y values from minus 2 up to and including 3. So that's a rough definition of the domain and the range. The domain's all the possible x values. The range is all the possible y values. And either we can look at that through some ordered pairs, or we could look at the domain and range through the table of values, or probably more often we'd look at the domain and range when we're given a function, a graph of the function. So let's say we were asked to find the domain and range of this particular function that we've got drawn here. So there's a few ways that we can do this. One way is we could simply write it out in words. So we could use some words to describe this graph here. Now, a couple of things here to know, maybe this is new for you. when you see an open circle here at the end of the graph, that means that this point here is not included. And when you see a solid dot at a point, that means that we are including this point at the end. So the open circle means it's not including that point. When it's filled in, we are including that end point. So if we were describing this, my domain, and we use D for the words domain, would be all x values, because the domain is the x value, all x values greater than -4, so not including -4, so all x values greater than -4 and less than, so we go basically from -4 all the way to 4. That's our domain. The possible x values on the horizontal axis would be from -4 to 4, but not including this number. But because this is filled in, we can include the 4. So we would say all x values greater than -4 and less than or equal to +4. So if we were describing the domain, we'd say all the x values greater than -4 and less than or equal to +4. So that would be our domain. Our range is how far up and down our graph goes. So I'm going to start here at the bottom. It looks like I go down to -2, and then I include -2, and I go as far up as 3, but not including 3 because we have the open circle. So our range would be all y values, and we would say the y values need to be greater than or equal to -2 and less than but not equal to, so just less than 3. So the domain, all the x values greater than -4 but less than or equal to +4, and the range would be all the y values greater than or equal to -2, we got a solid dot there, but less than 3. Now that's a lot of writing. So typically we don't want to spend all that time writing out the domain and the range. So another way we can do this is we can use what's called set notation. And this is another mathematical way of doing this. So we would write this domain. So far we've described it in words. Now we're going to describe the domain in set notation. We would say the domain is, and we use some brackets here. That's why it's called set notation, brackets. All x values. Mathematicians love to use symbols to represent words. If we can make things as short as possible, then that's a good thing, because we don't want to be having to write all these words out every time. So they've come up with a set notation. Domain, the set of all x, and then this vertical line always means such that. So the domain is a set of all x such that. Now what we do is we take our lower limit of x and we put it here, -4. And we take our upper limit of x, which is +4, and we put it here. And then we use these inequality signs. And then close our bracket. Now let me explain this one, because this one's a little bit complicated. It's simpler, less writing to do, but you got to understand a few things here. So the domain is the set of all x such that x is greater than -4 and x is less than or equal to. This little line under here means equal to. So remember, we could include this endpoint. So we have less than or equal to 4. So this little symbol here means less than. And this little symbol here means greater than. And when you're looking at this expression, if we read it this way, if we read the sentence this way, this would read x is greater than -4 And when we read it this way, x is less than or equal to 4. So that's how we express the domain of our function using set notation. And just remember this little symbol here, the big thing here, this is, I don't know if you played Pac-Man or whatever before, but if you kind of draw a little circle around there, you get the little Pac-Man symbol. And he always wants to chomp on the thing that's bigger. So if you look at this thing here, if we make the Pac-Man symbol, he's going to chomp on x here. That means x is bigger than -4. And if we make the little Pac-Man symbol here, he's going to want to chomp on 4. 4 is bigger than x. So that might be useful to help remember what to write. So once again, domain, the set of all x such that -4 -4 is less than x, or we could read x is greater than -4, and x is less than or equal to 4. So for the range, this would be y. The set of all y values, now our lower limit was -2, we put that here. Our upper limit was 3, we put that here. The -2 we can include, so we have less than or equal to. The +3 we can't include, so we just have less than. So now we have all the y values greater than or equal to -2, but less than 3. So all the y values from, and close the bracket off. So the range would be all the y values such that y is greater or equal to -2 and y is less than 3. So that's set notation. Yet another way we could describe the domain and range of this function is we could use a number line. And you're probably familiar with this method. So the domain, what we would do is draw a number line here. And we have to go from -4 to +4. So I'm just going to go up by 2's here on my number line. Go down down by 2's. And again, I would just have an open circle on the 4 because I can't include, on the -4 because I can't include -4. And I'd have a solid circle on the +4. And then I would shade all the numbers, solid dot on +4. Shade all the numbers in between there. So looking at this number line, I can quickly tell the domain of this function are all the x values greater than -4 but less than or equal to +4. And on the range, we would do the same thing. This time, because I've got some odd numbers, I'm just going to go up by 1. And the y values go from -2, including -2, so I'm going to fill that in, that circle. And they go all the way up to 3, but not including 3, so an open circle. And shade in between. And so the number line could also be used to find the domain and range of a function. Yet a fourth way of finding the domain, or expressing the domain and range of a function, is to use the interval notation. This notation here is probably even the simplest one to write in terms of the actual amount of effort required to expressing it. What we do is we simply use some brackets. Now, what we do here is there's going to be some brackets like this, and the lower limit's going to go here, and your upper limit is simply going to go here. And then we have some square brackets around to let us know that we're going to include these endpoints. So if we're looking at the domain, our lower limit is -4, and our upper limit is +4. So if we're going to express the domain, we just go -4, +4. And then the brackets at the end actually tell part of the story as well. So I could include this point here. So I do a square bracket on that end. And on this one here, this endpoint, -4, I can't include it because it's an open circle. So we do a round bracket on that one. So interval notation looks like this. The lower limit goes here. The upper limit goes here. And then we've got a square bracket if we can include this point, and we have a round bracket if we can't include this point. So really, when you see something like this, this is expressing the domain of the function. It's all x values greater than -4 and less than or equal to, because we have a square bracket, +4. And so then the range would look like this. I'm going to have my lower limit, which is -2. I'm going to have my upper limit, which is 3. -2 has a filled in dot, so we can include that endpoint. We'll have a square bracket on that. But our upper limit 3 is an open circle, and we can't include that point, so we put a round bracket. So there's 4 different ways how we can describe the domain and range of this function. Now we'll look at another example and go through these 4 steps again. In this example here, you can see we've got our graph that starts here and moves on and up to the right, and this arrow implies that it just continues to go up slowly and farther to the right. So let's describe the domain and range of this function in terms of those 4 ways of doing that we looked at in that last example. So if we were describing this in words, we could say the domain is all of the x values greater than or equal to -3. In other words, this graph starts here at -3 and it moves to the right forever, keeps going to the right. So domain, all the x values greater than or equal to -3. And the range, which is how far up and down our graph goes, well, it's all the y values from -2 on up forever, because this graph keeps going up forever. So we would just say the range is all the y values greater than or equal to -2. Now, if we were going to write this in set notation, the domain would look like this. The set of all x values such that x is greater than or equal to -3. So we want x values bigger than or equal to -3. Now I didn't mention this in the last example, but we could also write this, like describe what x is. So at the end we'd go comma xer. So xer just is another shortcut way of saying x is an element of the real numbers set. Or in other words, x can be anything greater than -3. It can be -2.2, it can be fractions, could be decimals, could be irrational numbers. It's all real numbers. If that's not written there, then it's assumed that what you're doing is that x is an element of all the real numbers. X can be anything there. So we got the domain x, the set of all x such that x is greater than or equal to -3, where x is any real number. And for the range, the set of all y values such that y is greater than or equal to -2. And again, y can be any real number greater than -2. And then we've got our number line. And so that could look like this for our domain. All right, domain goes from -3, so -3 would be right here on my number line, and I need a solid dot on it because I'm including that point, and we do a little arrow like that indicating that it is everything greater than or equal to -3. And for range, we want all the y values greater than or equal to -2. So it would look like so. And then finally, using our interval notation, for our x values, we want our lower limit to be -3 including the minus 3, so we do a square bracket on minus 3, and our upper limit is infinity, and this is the symbol for infinity. It just keeps going to the right forever. And since technically you can never reach infinity, mathematicians have said we'll always do a round bracket anytime we have infinity. So, whoops, that was D for domain. R for range. We have our lower limit of minus 2, including minus 2. And our upper limit is also infinity. And round bracket on the infinity. So there's the domain and range of this function described in words, set notation, number line, and interval. And we'll look finally at one last example here. Sometimes we might be given a relation in terms of a table of values and asked to describe the domain and range of this relation. So in words, we would simply have to list them out. The domain is the following x values. The x values minus 2, 0, 3, and 7. And the range would be the y values minus 1, 2, 4, and 5. Usually we write them from lowest to highest in ascending order. That's fairly typical. We could use the set notation. So set notation would be for domain, the set of all x values such that x equals, and you'd have to list them out here. And range would be the set of all y such that y equals negative 1, 2, 4, and 5. But usually we don't use set notation to when we're just listing a certain set of numbers. We would just write this as a list because we don't really need the set notation. So we would just say the domain is, and we would use those little brackets, and then we would just list them out. Negative 2, 0, 3, 7. And for range, brackets, negative 1, 2, 4, and 5. So the set notation is really mostly used if we have a whole bunch of numbers, like a range of numbers like we had on those graphs, where we had more than just certain specified x values. So if you've got a table of values or some points, then it's common to just write them as a list. But a list is not something we can do when we have a graph that's continuous over a long spread of x and y values. And really we can't use the set notation, the one with the brackets like this, because we don't, or sorry, the interval notation, because we don't have an interval of values here, we just have a list of them. So when you have a table of values or some points, the most common way is to write a list. You could also use a number line, I suppose. So for domain on our number line, oops, we're going to have to go to at least 8 here. Let's start this again, sorry. Two, 4, 6, 8, minus 2, minus 4. So on my number line, I would have a dot at minus 2, a dot at 0, a dot at 3, and a dot at 7. And so that would be a way of representing the domain using a number line, is to just simply put some dots on your number line. And we would do the same thing with the range. And so at minus 1, we would have a dot. At 5, we would have a dot. At 2, we would have a dot. And at 4, we would have a dot. And so the dots would represent the range of this particular function. So again, when your relation is expressed as a table of values or as a set of points, then probably the list is going to be your best way to to simply represent the domain and range of the function.